roof of the building and there is another taller building across the way with an open window at the same exact height as the building you are standing on. Your job is to build a bridge that will reach exactly from the top of your building to the open window. The information you are given is that there are 2 ladders, and each of them are leaning against one of the buildings at the top and resting on the opposite building at the bottom of the street. One ladder is 20 feet tall, and the other ladder is 30 feet tall. The height from the street to where the ladders intersect is 8 feet tall. You may also assume that the buildings are parallel to one another. And I'm going to put it right up here so that you can review. You're standing on top of the building, the small, the shorter one. But all I want you guys to be doing is drawing a diagram right now. You don't have to actually start figuring it out. I'm gonna put it up on the board and we're gonna compare all at once. Has everybody got a chance to draw at least something on your piece of paper? Okay, does anybody want to volunteer to come up here and show the diagram that they drew? Claire, I saw your hand first. Okay, so Claire has one ladder that's 30, one ladder that's 20. Here are her 2 buildings, and then the height is 8 feet right here from the street to where the ladders intersect. Thank you. So this is the diagram that I drew. I didn't actually draw the buildings per se. I drew the triangles because you can imagine that the buildings are these edges right here, and the ladders form the triangles. So we actually have 4 triangles in our diagram. Does everybody see that? Okay, so now that everybody has an idea of the diagram, I want to brainstorm how we can figure out the distance from D to across the way to this window right here. So what kinds of equations, relationships, or theorems could we use? This is just a time of brainstorming, so just throw out ideas.
Well, to find the difference, the distance from D to H, you find the hypotenuse of the IJH triangle using the angle there and the side.
Okay, so you said the distance from D to H?
Yes.
The distance from D to H is 20 feet.
Oh,
so we already know that.
From I to H.
From I to H. Okay. So you said, I'm sorry, can you restate what you said then?
Maybe. So if we want to find out the distance between I to H, then we figure out why right now. But we could use the what we know about trigonometry to find that hypotenuse on the H angle that's
okay. So are you trying to say you want to use like the Pythagorean theorem?
Sure.
Maybe. A squared plus B squared equals C squared?
Sure.
Okay.
I confused you myself.
Okay, so we've been talking about congruent triangles and similar triangles, so could we use something like that? Maybe down the line, if we get more information?
Yes.
Kayla?
I wondered about similar triangles.
Similar triangles? Okay.
Could you draw like an imaginary dotted line for the distance you want to find on your diagram, and then it makes other triangles you can solve for?
Like that?
Yeah.
Well, like, you know that you have like two big triangles with 90 degrees at the bottom. So
Okay.
I don't know.
So are you trying to visualize breaking up the triangles maybe?
Yeah, because like
Okay.
you need to find a couple different values in there, and if you know the degrees, I think that you can like sine and cosine for that or something.
Okay. So we have two parallel lines, right? Because the buildings go straight up. What about angle relationships? What kind of relationships could we possibly have with the parallel lines and the two ladders cutting those parallel lines?
I don't know how to say it exactly, but one of the angles on one side is the complement of the angle on the other side.
You're close. I think what you're trying to say, Sam, do you?
I think the angle Fij is equal to FEH. I don't know if that helps with the parallel lines.
So that property would be same side interior. That's what that property is called. So we're just going to say for right now, angle relationships are going to be important. I'm trying to solve this problem. Okay. So these are the theorems and equations that I came up with when solving this problem myself. I have ratios down there because if you have similar triangles, you can write ratios of their corresponding side lengths and they will equal each other. So that's going to help us solve the problem as well. Okay. So what I want you to do is work in groups and actually try to start solving this problem. And I will be coming around and helping you with questions. And if the whole class gets stuck, I have hints to help you all along.
Do character analysis on we decided that trying to build a princess dangerous, and so we'd rather just the kids. I imagine it's pretty great.
That one. Have 90 degrees.
Angles.
Right.
All those squared letters. I'm guessing that this and this are 90 degrees. Yeah, we need you.
What are you getting? Lift up with
We got it.
Hey, Kayla.
So that makes sense. Yeah. Because they have 45. Okay. If this whole line is coming, you know that this is 90 degrees, right, Gil, is that what you're saying?
So this that's one thing English is so do well together.
I'll teach you drawing.
I wanted to write a story about the interaction happening. So I corner.
I feel like if these are the same angle and this is a 90 degree angle,
Take that and figure out the other.
I give up.
Or is that not?
You don't really have to figure out any other side lines.
Figuring out how long.
But what actually we wanted to split up the diagram in 4 different triangles, and if you actually draw those triangles out.
So we know this side and we know this side.
No,
Yeah, you're right.
I think I see what you're saying.
Say that's
So, long story short, how long is it from building to building?
Long story short.
Yeah, who are you?
The other side is actually
Like, how do you cosine and measure like, how do you know where this to this is?
Agreed, Megan.
Can we come back into class? Drink coffee. Okay, so I'm running out of time, and it wasn't my intention for you guys to solve this problem. This would be in a 10th grade-ish geometry class, and it would be an application problem. I would give the students a lot of time to work on it, days, maybe even a week of time to collaborate together, because it is a more difficult and challenging problem because it is applying what they have learned, which sometimes students freak out about. These are the hints that helped me solve the problem when I was actually going through it. So you can look at that. And let's see. And I also just wanted to summarize the whole reciprocal teaching idea. So the first part of it was I was reading you a story and you were predicting what our text would look like in math. So that was the prediction part, which is the first step of reciprocal teaching. And then after that comes the questioning part, where students either ask me questions or ask each other questions to try to solve their predictions or just to get their curiosity going. And then you clarify, so that was me. This would be like the hint part, or me walking around the classroom and answering student questions, or actually students answering other student questions is the goal at the end of reciprocal teaching. And then comes the summarizing part, and we didn't get to that, but this is my outline. And so for the evaluation part is where they would summarize. So each student will turn in his or own summarization and solution of the problem. After that, the class will decide on a final solution. Then, as a class, the students will actually construct their bridge based on their calculations to see if their solution was correct. And then afterwards, they will reflect in a journal entry on the mistakes and the process they took and the experience they had solving the problem. So that's reciprocal teaching in a nutshell.
Just a couple of comments as we're making a transition. Reciprocal teaching